Hi everyone, in this video we are going to discuss about the general equation of a circle. In a previous video we have already seen the fundamental equation of a circle, which looks like this: x minus h whole squared plus y minus k whole squared is equal to r squared, where the center of the circle is located at h comma k and the radius is equal to r unit. From this fundamental equation, we are going to try and get a sense of the general equation. So first thing we need to do is we need to get rid of the parenthesis. So let's expand the whole squared there. The first whole squared will become x squared minus 2hx plus h squared, plus the second whole squared will become y squared minus 2ky plus k squared. And then the r squared on the right hand side, I brought it back to the left hand side so that I can make the right hand side 0. So that positive r squared coming to the left hand side became negative r squared, and all of that is equal to 0. In the next step, let's write down the x squared and the y squared terms first, and then the x and the y terms, and then the constants. So our equation is going to look like this: x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus r squared is equal to 0. And the equation of circle in general form is written like x squared plus y squared plus 2gx plus 2fy plus c equals 0. The coefficient of x squared is 1, the coefficient of y squared is also 1. The coefficient of x is usually written as positive 2 times g, that's in the general form, and the coefficient of y is written as positive 2 times f. And the constant terms there, h squared plus k squared minus r squared, that is represented by a lowercase c there. So this is the general form of the equation of a circle. Now let's compare the coefficients of the x terms in both the equations. So here you see negative 2h is equivalent to positive 2g, and from there we can say then definitely h will be equal to negative g. And similarly, let's compare the coefficients of the y terms between the two equations. So negative 2k is equivalent to 2f, and from here we can say then k will be equal to negative f. Again, if we think about h equals negative g, can that be written as negative half of 2 times g? That means we can say that h will be equal to negative half of the coefficient of the x term in the general equation, and h is nothing but the x coordinate of the center of the circle. So the x coordinate of the center of the circle is equal to negative 1/2 times the coefficient of the x term in the general equation. Similarly, if we think about k is equal to negative f, and that can be written as negative 1/2 of 2 times f, and that is nothing but negative 1/2 of the coefficient of the y term in the general equation. So the y coordinate of the center is equal to negative 1/2 of the coefficient of the y term as in the general equation. Next, let's take a look at the constant terms there between the two equations. In the first equation, h squared plus k squared minus r squared is equivalent to the lowercase c in the second equation, which is the general equation. And from here, can we say then r squared would be equal to h squared plus k squared minus c, and then r would be equal to square root of h squared plus k squared minus c. I am taking the positive value here because it's a radius. A radius can never be negative. Radius should be positive always. It's the radius of a circle. It should always be positive. So I have taken the positive value on the square root. Also, we know that h is equal to negative g, so we can write h squared as negative g whole squared, and that is essentially positive g squared. And similarly, we know k is equal to negative f, so k squared would be equal to negative f whole squared, that is again equal to positive f squared. And from here, we can then say that r will be equal to square root of, in place of h squared, I have written g squared, and in place of k squared, I have written f squared. So here is another form of the radius of the circle that can be written as square root of g squared plus f squared minus c. So now we see two forms for the radius of the circle. Next, let's talk about the nature of the circle. How can we determine what kind of circle it is based on the general equation of a circle? If you look at the value of the radius, that is equal to square root of g squared plus f squared minus c, since it is under a square root, this value has to be non-negative. That means it has to be greater than or equal to 0, otherwise the radius will be imaginary. So now, depending on the value of g squared plus f squared minus c, we can make a good guess about the nature of the circle. So there are three possibilities. G squared plus f squared minus c can be greater than 0, g squared plus f squared minus c can be equal to 0, or it can be less than 0. When g squared plus f squared minus c is greater than 0, the value of the radius will be a real number. So the radius is a real radius, and of course there will be a real circle. And then let's talk about the third scenario, then I'll come back to the second scenario. So in the third scenario, we have g squared plus f squared minus c is less than 0. That means it's a negative number. That means we have an imaginary radius, and imaginary radius means no real circle is possible. We really cannot draw a real circle. So if you ever see this type of an equation where g squared plus f squared minus c is negative, then it is actually not the equation of a real circle. Next, let's talk about the second scenario where g squared plus f squared minus c is equal to 0. Now, if that quantity is equal to 0, then obviously the radius will become 0. And if the radius is 0, then how is that circle going to look like? Well, that circle is actually called a point circle. It's like a tiny little circle, but only one point satisfies that circle, and that point is the center. So as if the circle became smaller and smaller and smaller and smaller and smaller, ultimately it ended up in a point, in a single point, and that point is again nothing but the center of the circle. Let's see how it is just the center of the circle that satisfies that equation. If you think about the fundamental equation here, which is x minus h whole squared plus y minus k whole squared is equal to r squared. H and k, they are the x and y coordinates of the center, r is the radius. Now if r is equal to 0, then x minus h whole squared plus y minus k whole squared will become 0. If we have the sum of two squares equal to 0, then definitely each square term has to be equal to 0, because the square of any real number can never be negative. It could either be 0 or positive. In this case, the sum of two real numbers square is equal to 0. That means each squared value will be equal to 0. So from here we can say x minus h whole squared is equal to 0 and y minus k whole squared is equal to 0. And from here what do we get? Well, obviously x minus h will be equal to 0 and y minus k will be equal to 0, and that definitely means x is equal to h and y is equal to k. That means there is only one point that satisfies the equation of the circle, and that point is actually the center of the circle. The circle is so small that it looks like a single point, and that point is nothing but the center of that circle. So that is why this type of a circle would be called a point circle when g squared plus f squared minus c is equal to 0. So if you ever see an equation where g squared plus f squared minus c is equal to 0, that means it's not a real circle as such that we can see. It's like a point circle. It's like just a single point. In the next video, I am going to solve a few examples. I hope everything made sense so far. Thank you for watching. See you in the next video.